A great philosopher once said that we are all connected to each other biologically, to the earth chemically, to the universe atomically. And that philosopher was Neil deGrasse Tyson. One such connection is the compounds we have in common with Mars, methane and water. Both of these discoveries are the strongest evidence so far for life on Mars.
You might be asking, how do these two compounds equal life on an otherwise barren planet?
That's a great question. On Earth, methane is most commonly found where life is. One such place you can find methane on Earth is landfills, sewage, and livestock waste. It's created by an anaerobic microbe called methanogen, which breaks down carbon dioxide molecules and leaves the byproduct methane. In June of 2019, rover Curiosity found methane on Mars, which is significant given the methane is broken down by the sun quickly, indicating that the emissions were recent. Another essential element of life is water. This substance is important because it provides the mineral-rich environment for microbes to survive. The hydrogen bonds in H2O allow water to hold heat better than other substances, allow for surface tension, and make an excellent solvent. Compared to Earth, Mars' track record with water looks pretty bleak.
Mars is smaller, drier, and lacks the shifting tectonic plates that, on Earth, bring in fresh minerals through cracks in the planet's crust. However, the following data indicates the potential of life on Mars.
Despite that, in 2018, Italian scientists working on the European Space Agency's Mars Express mission found a 12-mile underground salty lake near the Martian South Pole, residing beneath an ice cap, which potentially protects life underneath from the punishing radiation levels beating down on the surface. Bodies of water resembling these conditions in Antarctica and Greenland show that microbes living in deep, cold environments can adapt.
A. Going into a state of suspended animation are slowing their metabolism to deal with low food source. B. Feeding on the minerals rocks provide. Or C. Feeding on sulfur compounds, sulfates, and excreting hydrogen sulfide.
So, what kind of life would we find on Mars if methane and water are indeed viable? Well, it's difficult to say given the randomness of nature. Who's to say that Mars won't develop organic bacteria that just hang out there until humans don't exist to wonder anymore? Regardless, here's what any life would have to withstand.
Incredible lung filtration capacity, a tolerance for extreme cold, and the ability to migrate, hibernate, or suspend animation. Any life would also be comparatively much weaker than the flora and fauna of Earth due to the following. A. Mars is a consistently cold, dusty planet with air 50 times thinner than the peak of Mount Everest, making it difficult for the atmosphere to heat. B. Mars is only slightly bigger than half the size of Earth. This means it has lesser gravitational pull. The latter is only 38% of Earth's gravity. Half the year, the sun facing half of the planet experiences summer and spring, and the cold, dark equivalent experiences a long fall and winter. The temperature of Mars reaches a maximum of 70 degrees Fahrenheit, negative 225 degrees at lowest, and negative 81 degrees on average.
So, what does this mean? With the data that we gathered, we can conclude that Mars might have the potential for the basic building blocks of life.
However, Mars is still missing a couple advantages Earth has, such as a hospitable atmosphere and temperature, in addition to dynamic tectonic plates.